Alright students, example number 2 is in front of us, which says differentiate tan of root of x using the first principle. So in this again we have taken first the tan root over x as fx. So in place of this x, if I am writing x plus h, then this in place of this x it will be x plus h square root. So fx plus h is equal to this much and fx is equal to tan root over x. So now we have, if we have to find out the d dx of tan root over x or f dash x or dy by dx, where y is nothing but y is equal to tan of root over x. So if you have to find out this dy by dx or d dx of tan root over x, then by first principle you have to use this particular formula, which says limit h tends to 0 fx plus h minus fx whole divided by h. In place of fx plus h we have written tan of root over x plus h, and in place of fx we have written tan of root over x. Now this tan root over x plus h is written as sine root over x plus h by cos root over x plus h minus tan root x is written as sine root x divided by cos root x. Then simply we have taken the LCM of the denominators, that is cos root over h plus h into cos root h, which is what is written over here. And then with this, if we divide this whole thing, then cos root over x is left. Cos root over x multiplied by sine root over x plus h is giving you this much, minus sine I have written over here. Then with this cos root over x, when this whole thing is divided, then cos root over x plus h multiplied by this gives you this sine root x into cos root over x plus h. If you see carefully this numerator, then you will find this is in the form of sine a into cos b minus cos a sine b into cos a. So that is what I have written in the form of sine a minus b and whole divided by h multiplied by this thing, which is copied over here. Now what we find over here is the sine root over x plus h minus root x is first divided by root over x plus h minus root x, means whatever is there in this one, same thing is divided over here and same thing is multiplied over here. I hope you can understand this. And h multiplied by cos root over x plus h, cos root over x is copied as it is over here. Now why we have done this thing is because of this formula where I have written, yeah, this limit h tending to 0, theta tending to 0, sine theta by theta is equal to 1. So we have to bring this whole thing in the form of theta, and this one also theta, and that too theta tending to 0. So as you see, when h tends to 0, that means this and this, then in the numerator we have root x minus root x, which becomes 0, and this also becomes root x minus root x, which is 0. So this forms sine theta by theta, where theta tending to 0. That means this whole thing will become 1. That is what I have written over here. First this step is followed, and after that this is written as 1. After that you can see that root over x plus h minus root over x is rationalized by multiplying the same quantity over here. Difference is, in place of minus we have written this plus. Alright, so in the numerator and denominator both the same quantity is multiplied, and h multiplied by cos root over x plus h, cos root x is copied as it is. Now as you see, this thing becomes your 1, and this is nothing but it is in the form of a minus b into a plus b, so that we have written root over x plus h whole square over here minus root over x whole square, and denominator remains as it is. Now this square root sign will be removed with this square sign, so that this becomes x plus h minus x. X are getting cancelled, only h is left. That h and this h will be cancelled, and we are left with only limit h tending to 0, this whole quantity. Finally when h tends to 0, then this becomes root x plus root x, that is equal to 2 root x, and over here we are finding cos, this h becomes 0, then cos root x into cos root x will give you cos square root x. This cos square root x, 1 divided by cos square root x will become sec square root x whole divided by 2 root x. That is your final differentiation of tan root x. I hope till this point it is clear to all of you. Thank you.